All right, so we're factoring, and on each of these you want to look and see, first of all, always if there is a common factor. So if you look at this first one here, we have a 10 that's common in both of them. And we actually have an x squared that's common in both of them. So we're going to take out a 10x squared. And when we do that, we end up with an x cubed left over in here, and then just simply a minus 1. Now this is a difference, but this is not a difference of two squares. This is a difference of a cube and a square, I suppose. So this one is actually completed. Alright, so let's go ahead and look at the second one. I also see that there's a common factor here. So there is a common factor of a 4 in each one of them. And there's also a common factor of an x squared in each one of them. So I'm going to pull that out of each. I'm left with a 3x cubed. I'm left with a 2x squared. And I'm left with a 2. Now this is not factorable. This is not a quadratic. So I am finished with that one. Let's go ahead and look at the next one. Again, common factor. Hopefully you're seeing a theme here. So we take out our common factor of our 4. We're left with x squared minus 1. Now, this one actually can be continued. This one here is actually called a difference of two squares. So that would be factored as a square root, square root, square root, square root, and different signs. To multiply this out, I would have gotten x squared, which does give me my first one. I would have gotten negative x plus x, sorry about that, which would cancel those, and then I would get a negative 1. So this would indeed multiply out to get what I'm looking for. Go ahead and look at our last one. Again, the common factor is what we're looking for, so we can actually take a 2 out of all of those. I'm left with x squared plus 4x plus 4. So now we do need to factor this. And so we're going to go ahead and do our diamond problem. 4, which is actually that 4, goes on top. And this 4, which is actually this 4, goes on bottom. I can color code that. This 4 is this 4. And this 4 was that 4 there. So I am trying to find out what would I multiply to get the top. This is multiplication, and then combine to get the bottom. And so 2 and 2 would work for me. And so I end up getting x plus 2 and x plus 2. Now, if you wanted to write that as x plus 2 squared, that would be even prettier. All right, we're going to go ahead and continue with this look of expressions that have two terms in them. If they just have two terms, as of right now, you can either take out a common factor as one option, or the only other option we have is if this is a difference of two squares. So the square root of this is 4, and the square root of this is 3x, so this is absolutely a difference of two squares. So you should be happy, happy, joy, joy, jump all around like crazy, because you just don't get any easier when you are factoring it. So it's the square root of the first, the square root of the last, square root of the first, square root of the last, and different signs. When I multiply this, I do get 9x squared. Check. I do get minus 12x plus 12x, canceling out. And I do get negative 16, check. So that one does work indeed. Let's go ahead and look at this next one here. This is a perfect square. The square root is x. This is a perfect square. The square root is 1. So I have my factor. We multiply it out just to make sure it works. We get x squared, check. We get minus x plus x, those cancel out. And we get negative 1, check. So it definitely does work. All right, these next two, as you can see, are trinomials. They do not have a common factor. There's not an x in all of them, nor is there a number as a factor for all of them. So each of these, we're going to go ahead and use our diamond problem to start off with. So we would get what? Negative 5 and 4 would work for that one. Now, if there is no first coefficient, I like to say it's diamond and done, meaning you just use those fancy Dan little numbers that you got there, and you're done factoring it. Now check it. We have x squared, check. Minus 5 plus 4 is a negative 1. Minus 20 totally works. All right, let's go ahead and do our last one here. So we do a little diamond problem. We have 42 and 13, which is 7 and 6, both positive. So we get, again, diamond and done because there is just a 1 in front of that first coefficient. So I like to say, if there's a 1, then it's diamond and done. Does that just sound catchy? All right, let's go ahead and factor it. We have x plus 6 and x plus 7. We take 2 seconds just to quickly check to make sure that that really works. We have x squared, that works. We have plus 7 plus 6 is a 13, and we have 42, so it totally works. Again, that takes about 3 or 4 seconds just to check it to make sure that you're right. All right, we've got last two now. This is not a 1, so it's not going to be diamond and done, but we do still use our diamond problem to figure out what our numbers are. So we have a 12 and negative 8. Which would give you, what, negative 6 and negative 2? Yeah, that'll work. So at this point here, we're going to rewrite it. In other words, we're going to take this guy here and rewrite it with these guys here. So, and then we're going to go ahead and look here and see what's common. Just x, really. So I have 3x minus 2. And I'm really, really hoping that when I factor out, let's see, a negative 2, I'm left with 3x minus 2, which is good. These two things must be exactly the same. So now I look at this whole guy and this whole guy, and I notice that I do have a 3x minus 2. And then when I pull it out of here, I'm left with this guy here. And when I pull it out of here, I'm left with this guy here. Now, we want to check this. We want to make sure that we actually have the right answer. So we do have a 3x squared. That works there. I have negative 6 minus 2, which is my negative 8. And then I have positive 4, which is my positive 4. So I'm good. All right, we are on to our last little one here. So we have, what, negative 6. So remember, you have to multiply those two numbers together to get the top. And then negative 1 is on the bottom there. So that would be a negative 3 and a positive 2. This is not a 1, so we are not diamond and done, which means we need to rewrite this middle term with these little dudes here. And then we are going to be factor by grouping, so we want to figure out what is common between these. We have a 2x here. We're left with 3x plus 1. And when we take out a negative 1, we're also left with 3x plus 1. Now, these little dudes are exactly the same, and that is good, because we are now going to look at this grouping and take out that little 3x plus 1 out of both of them. And what you are left with is this stuff here. And you are also left with that stuff there. So now we check just to make sure. We have 6x squared, so that worked there. We have minus 3 plus 2, which is a negative 1, so that works there. And then I do have a negative 1, so that works there. So we are golden. All right, we're finished.